Hello, hello. Welcome to another episode of ShipTalk podcast, where we talk about the ins and outs, ups and downs of software delivery. I'm your host, Dewan Ahmed, and today I'm delighted to welcome Fatih Bulut, AI architect at Microsoft, working at the intersection of cloud, security, and AI, building systems that actually work, not just dazzling proof of concept. Welcome, Fatih.
Hi, Dewan. Glad to be here.
Where are you dialing from, Fatih?
I'm based in Boston, Massachusetts. Um, yeah.
Okay, not too far from here. I'm in New Brunswick, and it's not September yet, but it was single digit last night. When I say single digit, for my friends in the down south, I have to say I do in Celsius. So whenever I hear Fahrenheit, my brain goes off. So I have to do some conversion. So I guess you can say
Yeah.
Fahrenheit.
I mean, I can say it in Fahrenheit. It was a hot topic in our household yesterday as well. My parents are here from Turkey, and they're like, in August, this shouldn't be that cold, actually. Is this like normal? It was cold yesterday. Yeah.
Yeah, yeah, yeah. Well, we only get a few months of summer. So I was checking your LinkedIn and I saw that we have a common background back in the IBM days. So I'm gonna get started there. So we both spent time at IBM, different teams, but same giant playground. How was your IBM experience like?
Short, it was great. It was my first employer after my PhD. I worked at the intersection of AI for security and compliance for 8 years. I really enjoyed my time. IBM has been IBM was a really big company, and right now it's still a big company. And It's a foundational company to everything that even we use today. Um, if you think about like what IBM invented, is like the ATMs that we use in banks. Um, those are invented by IBM, like DRAM, even SQL, and I think Fortran. There are lots of things IBM invented and put into our life, PC, right? That it's a foundational to everything. It was obviously a very big company, and lots of units, and I was mostly part of the research part. And IBM has a very strong research culture. It's probably one of the few companies left in US which has a dedicated research unit. Over time, I realized, we are working more closely with the business units. But It was an enjoyable moment. I truly enjoyed my time. It was a rewarding experience working with really good people. I still talk with some of my friends there. It was a really good company, I would say, and it has a marks on my career.
On the topic of invention, IBM actually invented a cheese cutter. So when I was working at the Markham Software Lab, there was a giant cheese cutter, and there was like IBM on it. Like I could never imagine that IBM inventing a cheese cutter. Did you know that, Fatih?
Yeah, I mean it. I saw some of these machines, in some of the IBM locations, and it was really surprising. You think you're working for a tech company, and you see that, you think like, maybe not, but this was like maybe 50, 60 years ago or 70 years ago. IBM is like more than 100 years company, and they invented a lot of stuff, including like tabulating machine and all. Um, Punch cards, like all this stuff, right? I mean, it is a company that also transformed itself over time and many times, and probably they are, one of the such moments right now as well. So yeah, I mean, when you work at IBM, the transformation is something that they talk about a lot. which I think keeps the company alive for such a long period. If you compare it to some other companies that we talk probably more these days, but they're much younger companies.
Yeah, and talking about IBM, Fatih actually was a master inventor at IBM. So working at IBM, I know that that's a very prestigious level to reach at. Not many people can become a master inventor. If you could share with our viewers and listeners about what does a master inventor have to do to earn that title?
So it's a title that requires a few things. One is that you have to invent. Obviously, you have to submit patents. You have to file patents. And when you submit a patent, it goes through a review process, and then it will be filed, drafted, and filed to the patent office. So that's one part of it. Like you have to make sure that you continuously invent. And then one other thing is you have to also mentor others as well. So you need to make sure that the young generations and the people coming after you also start inventing as well. So that's also part of the evaluation as far as I remember. So once reach to some point where you have lots of patents, and you start mentoring people, teaching them how to submit and invent as well. So that's where you become eligible for becoming a master inventor. So those are the two main steps as far as I remember. One other thing I remember is that it's not a one-time process, so you have to sort of like recertificate every 3 years, as far as if I remember correctly. So it's for a period. You're a master inventor.
Talking about master inventor, so one topic that people fail to master is the difference between AI for security and security for AI. Even I don't quite get the exact concept. So you are the best person to explain to our listeners where do you focus and what are the difference between these two?
Yeah, definitely. I mean, it's a very confusing topic, because two words we use interchangeably in different places. So my focus is mostly on AI for security, and security itself is a really broad field where defenders try to protect uh, enterprises, companies, environments, cloud or not, from bad actors, right? So it's a broad field, and there is the idea of like applying AI or bringing AI, infusing AI into the security. So this applies to, for example, let's take security operation center SOC into the account. How do we make the processes more efficient? How do we automate some of these using AI? And these are typical, AI problems that you may also find some alignment in different areas as well. So this is for AI for security, bringing AI into the security. But then obviously AI itself needs security as well. So that is the part of security for AI. So when we deploy the AI, we need to make sure that it's secure. And there are lots of attack vectors that people today take advantage of. For example, putting some prompts into their websites, which is basically not something you would like in a prompt. But when you read that website and automatically and then putting it into the context in your prompt, then it becomes your prompt. So now that it can be a prompt injection attack, for example, to extract some information such as system prompts and such details, even some other things that you're putting into the prompt at that point of time. So there is that part of like securing the AI itself. So that's the second part, security for AI. So that's the difference in short.
One other, since we're on the topic of similarities and differences, this is about software delivery, and the theme for season 4 is AI meets software delivery. How do you draw the parallel between the practices you are mentioning in security space and how we do DevOps and SRE? Do you see similarities, differences? Do the fundamentals of SDLC still hold?
I think the fundamentals still holds, in my opinion. So let's take, for example, detection engineering. When we say detection, it's basically a piece of code, and sometimes this piece of code can be as small as a SQL sort of like query. Sometimes it can be a gigantic like query. Um, Sometimes this is rule-based. Sometimes this can be an ML-based, machine learning-based behavioral detection code as well. So it varies a little bit, but at the end, it's a little bit smaller than like, a typical software product. The idea of detection engineering is that you have some idea around some of the threat vectors that you want to protect your organization. And these threat vectors can come from a variety of sources. Some of the sources are state-sponsored actors, like threat actors. They would like to get into your environment, take advantage of some of the data and all. So that's one sort of area that you would like to monitor. The second is financially motivated threat actors. These are actors who would like to, put some ransomware in your environment and, make some money. There are like all sorts of hackers as well. And you would like to, understand your threat landscape first. Once you understand your threat landscape, you would like to make sure that whenever these behaviors of hacking, and this could be in variety of ways, if it happens, you would like to catch them. So to catch them, you rely on the telemetry and logs, which is basically bread and butter in security. And to be able to analyze this telemetry and logs, you need some piece of software such as detection code to analyze these logs and look for patterns. For example, for a password spray attack, you would see logs that passwords, different passwords are like entered multiple times. So if you catch such things, you look for such things in the detection code, and if you catch it, you generate an alert. So that's sort of like a typical detection engineering, and it's basically you need to develop a code. It's very similar to, if we think about it, how we develop software features as well. So we have some features, and then that features turn into some code by a developer, and then the developer needs to test this code and then make sure that the quality is there. And then it goes through the CI/CD and all, and then it's shipped into the production. So similarly, when you generate detection code, you want to make sure that the quality is there in terms of all the tests and all, and then it goes through the test and then went into the CI/CD and to the production. One difference that I can tell is that when you're shipping a code in a software, your typical metrics are probably if the feature is complete, if the thing that you would like to do is there or not. Maybe it's binary, not all the time. But in detection engineering, your typical metrics are a little bit different, because what you're interested in here is, first of all, do you catch the behaviors that you're targeting or not? So that's sort of catch rate maybe. The second thing is, you would like to make sure that you're not generating lots of alerts. So you may write a detection that catch lots of such behaviors. But if you generate lots of alerts, then it's not very useful either, because the Security Operations Center, where they will look into the alerts and incidents and will try to make sense of it. If there are lots of them, they will basically reduce the value of the alert. So that's why one of your metric is to make sure that you're not generating lots of alerts. your signal to noise ratio is high. So it's somewhat different, right? If you compare to the software development lifecycle. But at the end, it's both software, so you gotta make sure that the quality is there, tests are there, and everything is there. Maybe the beginning and the end differs a little bit in terms of the research and the metrics that you are focusing on.
Yeah, when you're explaining that, I could relate to how we're designing like pipelines, like CI/CD pipelines. So when I'm trying to deploy to production, I could have some metrics. So let's say I have a CV or continuous verification module, which is looking at certain metrics like CPU usage, call per minute. And if it reaches a certain threshold, so let's say I'm not going to allow that artifact to be deployed, and it can be manual. Someone can get a notification. It can be automated. The pipeline will just revert if there's a rollback. One other thing I'm thinking is proactive versus reactive. So looking at certain metrics and trying to prepare in advance versus something happened in production. Now, how can we quickly revert that? So in the security space, have you can you think of something similar of a proactive versus reactive? Like can you find a pattern of these bad actors beforehand, before something happens?
Yeah, I mean that's pretty much like, the idea in detection engineering. So you really wanted to be prepared when that time comes, you really catch them. And usually when an attack happens, it doesn't happen in like one behavior, so it happens in multiple phases. Some attackers like, just go into the system. Um, let's say they compromise the password of a user, they get into the system, and then they move into the uh, other machine from there, and take advantage of some of the other vulnerabilities. So it's basically there are phases, right? It's not just one action. And there, from a defender's perspective, you have multiple opportunities there. Like, let's say if you couldn't catch them in the first place for multiple reasons, then there is the second opportunity. And sometimes it can get tricky because some of the attackers are really complicated and sophisticated in a way that they can stay stealthy for a very long time, waiting for the moment. So those are very complex use cases, but at the end, like there are multiple opportunities, and you want to catch them, like in one of these instances as early as possible. It's the best way to catch it. But if it doesn't happen, there will be other opportunities as well. When it comes to the novel attacks, like maybe those are the areas where I think AI, ML sort of solutions can really, really help, because the sort of like attacks that we discussed, for example, password spray and all, these are very well-known attacks. And you can write detections to detect those. But then there are always like novel attacks that attackers can come up with. How do you detect those? If you haven't seen those before, how can we be more proactive to those? I think it's an open question, and I think AI, LLMs with the cognitive skills, reasoning capabilities, presenting a lot of opportunities in that space to be more proactive. But in general, security is I think, is a very proactive business where you have your detections, and if somebody acts, you basically create an alert and mobilize the teams, security operations center, whether to mitigate it, disrupt it, and all sort of like, mitigations.
Now, you have taken ideas from prototypes to general availability, a giant leap that a lot of people underestimate. What was the hardest part into turning something which is just in the research phase from something people can actually use?
Yeah, I mean, great question, Dewan. Like, there are a couple of things. First is that um, I think, like, people have a lot of ideas, and the main part that makes a difference in terms of having ideas and getting that into the people's hands is the execution. And when you lack the execution, a lot of ideas basically just stay in the paper, in PowerPoints, Word documents, or wherever it's written. So I see that lots of people have ideas, but to get to the point where it's actually useful, you really need to get this into the hands of the practitioners, whether this is a customer or if you're developing this for for internal purposes, whatever the customer is in this case. It takes a lot of efforts to get a research idea into the practitioner's hands. First of all, you have to deal with the problem of proving that the idea itself worth investment. So there are lots of scrutiny around that. Some people may say that no, this is not a good idea, and there are such things. So you have to make sure that you have the alignment. The second thing I would say is that, especially working on the research side, you have to make sure that you really understand the products, the customer sides. You can't just operate in silo and solve customer problems. So you have to make sure that you work very closely with the product teams and engineering teams, understanding their limitations. Sometimes they don't support certain functionalities that you would need in your solution, for example. So you want to make sure that you build your prototype and solution based on that, and also working very closely with the customers, and understanding their pain points and revising, iterating, getting to the point things are useful. Because when you build a POC, and you may think that it works and it solves the problem, but when you actually put this into the customer hands, then you started to realize that it actually doesn't solve the problem. Maybe it creates more problems, and it's very important that you build and establish that feedback loop with the customers, so that you can iterate and then make the solution much better. I think all of these needs to come together to get an idea from early research ideas to the production, to the customer hands. All of this needs to come together, and it's a challenging thing to do, but it's a necessity.
Couldn't agree more. And one of the challenging things is how we do software delivery, how we take a piece of code, turn that into software, and get it to customers' hand. How do you see AI affecting software delivery? Does it add complexity? Does it make things simple? And you can draw parallels between your experience on how you're using AI for security and how you see AI in software delivery.
I think this is the very hot topic right now that people discuss. There are multiple, I think, phases in software development, right? First, you have to develop the software, and right now there are lots of buzz around using AI agents like Cursor, Copilot, and all, to use them to generate the code. I mean, in my experience, I can see that they're really powerful. They can generate codes that actually work. But in the meantime, I also see limitations too. When the code base gets larger, for example, they started to struggle. And there are also patterns that I see sometimes can be annoying. I use this it's a plausible but wrong. They, for example, generate code to support legacy features, which you don't want to support sometimes because you're iterating, and you instruct the agent to not even to support it, but it tries to support it. So that's one of the annoying points I can see. The other thing is that I usually see is it basically it puts sometimes it can't solve the problem, um, but it puts some hard-coded like solutions, somewhat like a workaround solution in the agent's minds, I guess. Uh, it can't solve the problem, but maybe if I put this like hard-coded like strings and return this, it's gonna work, right? You think that if you don't look into that, you may think that it's actually working. Uh, but actually it's just like not the functionality that you want. It's a hard-coded string. So those sort of issues, like I think, is real problems in software or code generation, and we have to be very careful about this. But in the meantime, once you know that like how this works, some of the limitations, you become more cautious in terms of becoming careful on these stuffs, um, and you take this into the account and you generate, and you work better with the agent. I can see that like it improves over time. So looking back to the GPT-3, and then now coming into the like GPT-4 and 5, definitely AI has improved, and it generates more meaningful code and all. It's definitely useful, but we have to be careful because at the end, if the generated codes, somebody has to look into that. Somebody has to make sure that the quality is there, and I think we are not right there where we can just like use AI and trust fully. But I think AI is there and useful as a co-pilot. So that's where my opinion stands on this.
Yeah, I agree. I see it as a helpful peer, sometimes a junior engineer who'll do a lot of work for you, but at the end, it's your job as a senior engineer to ensure that the quality remains of the software you're delivering because it's your responsibility. On the
And,
top,
and and you also ask about like how security, for example, goes into that too, right? Some of the pieces are still missing. For example, if as a developer I use AI to generate the code, and if that code is vulnerable to something, uh, like who is responsible, for that code? Is the developer who committed that piece of code responsible? Obviously, there is some responsibility there. But then, how do we audit this? How do we go back and do forensic on this? What actually went wrong? What AI agent or LLMs? There are multiple options. Even like using Copilot, you see multiple like LLMs, and you can use. Which one actually was used? How did this happen? Like, did I use an MCP server, get some more context? Maybe that was the point. So lots of like security issues there as well. Like, how do we actually audit this? How do we make sure that like, if something goes wrong, we understand why? And so these are, I think, still open questions, and there are lots of security aspects that needs to come into the place. And but I think it's becoming more useful.
Yeah, I agreed. So when we think of the whole SDLC, like the life cycles from building software to building the artifact, delivering it, monitoring it, AI touches almost like every single bit. So Fatih, you talked about like code generation part, but what I see customers using AI or taking benefit from AI is, let's say they have to generate a pipeline. Harness AI, for example, in the platform, it gives you an option to generate a pipeline using AI. So you click a button and it generates the whole pipeline for you. There might be any issues if you have any specific use cases, but an experienced user, so let's say a DevOps engineer, they'll know that, okay, it did 95% of my work. Now I have to do some tweaking. I remember like 3 or 4 years ago, whenever there's a failed pipeline, I actually look at the pipeline logs, like just scroll through the logs, do a command F or some tail to find out what's the issue. Right now, there's a button like troubleshoot or find the issue for me. Again, with Harness AI, it reads your entire logs and tells you this is where maybe a package, maybe a version mismatch, and then you can same thing with vulnerabilities. If there are vulnerabilities for your SBOM, it can find out this is the issue, and it also gives you remedies. So this is how I see AI helping people who already did these things by hand, and now just taking benefit from AI and automation versus someone completely new. We hear the term vibe coding all the way from development to deployment. For them, again, it might do most of the work, but if there's an issue, it won't catch their eyes.
Yeah, yeah, definitely. I mean, um, I think one of the problem that we're currently facing with AI is definitely useful, but it also throws a lot of ideas as well. You know, for example, you have a code base, and you wanted to analyze this for issues, and if you ask AI, it may find you some novel patterns too. Yeah, you know, in some instances, there are some like papers and blog posts about that. Um, but in the meantime, it also generates noises too. It brings up issues that may not be a problem actually from a production perspective. So there's that problem as well. I think if we put the human at the co-pilot seat, and working along with AI, I think that's the way to approach this, at least for now. In future things may change, but for now, I think it's the best way to approach this. One of the problem that I think the fundamental problem that I can see in AI today is the architecture itself. And I mean, this is not my opinion, but some of the prominent figures in AI also tell this as well. The transformer architecture, right? So that the architecture itself is the cause of some of the limitations. I can easily see that sometimes when I use LLMs, it overlooks information. Even though the context window gets larger and larger over time, now we're talking about millions of tokens. Still, I can see that certain information and instructions are not followed even by the most powerful models that we use today. And these are some of the like biggest problems in security and operations as well, because the data volume is huge. So for example, when you deal with logs and telemetries, whether this is for an operations incidents or this is for security, the volume is huge. And to be able to take advantage of AI and LLMs in that space, you have to really make sure that what you put into the prompt as a context, is the one that you would expect that you try to get something out of it. So you need to really, put all the noise out of it. So there are some such limitations, but I think we are getting there. It's gonna get much better.
Yeah, yeah, totally. It reminds me of the Stack Overflow days that if I find a piece of code on Stack Overflow, it must be perfect to deploy to prod. So similar to that, like there might be an overconfidence on the models we have right now. Like AI is magic that you spring all over and then it must work. I think there has to be some sort of QA in how we generate code, how we deliver that code. And I'm talking in the context of AI because we are creating codes like never ever, never before. And this huge amount of code, like who's actually making sure that there is some QA? Again, we can bring AI into some sort of hopefully like AI QA or similar systems that will make sure that yes, the code you're generating it matches the mark, or the things you're deploying it also is free of certain vulnerabilities. It is good for production. But I think this is a very interesting time where many engineering teams will make mistakes and they'll learn from these mistakes.
Yeah, definitely. I mean, the one of the main driver of you know using AI, I think it's coming from the business itself, where now that we have this powerful tool at our hands, everybody would like to get more features, delivered, more products delivered, and I think that's fueling the use of AI a lot, um, because people, I think, now realize that this is something that they can use to expedite, some of these works and tasks. Um, and obviously, it comes with the pitfalls and with all the potential failures and potential drawbacks and security issues. But I think, as you mentioned, we have to come up with quality assurance there, whether automated or not. Obviously, I mean, we need some automation there, to make sure that, the quality is there. And if quality is not there, we stop there. We don't put this into the uh, or merge into the main to go into the production.
One of the places you're looking to add quality or look at the security aspect was Metaverse. So I came across your blog from 2022. You wrote about Metaverse and security. What led you to explore security in the Metaverse? And then our follow-up would be, how do you see writing blogs helping software professionals?
Yeah, I mean, it was a time, I think, 2022, maybe within the COVID or right after the COVID. Uh, I was working at IBM Research. I was tasked with looking into the metaverse security. Obviously, at that time around, the metaverse was a very, very, very hot topic. I remember even I think Facebook changed its name around that time, maybe a few years back or such. So it was a very hot topic. Everybody would like to do something in metaverse. Obviously, with my expertise, I was tasked with looking into the security aspect of metaverse. So that's like how I come up with that blog. I did some research, try to understand the landscape, and then think about what are the security aspects of metaverse. Interestingly, I mean, metaverse, we have avatars and all, and different digital entities. Um, Similarly, yeah, I think there are parallels in today's world where we have AI agents. In that, metaverse context, we were talking about identities. So how do we, for example, make sure that the identity is something that we can prove? How do we make sure that it's secure and all? Same problems that today we are dealing with the AI-based agents as well. When they operate, who's responsible on what identity that they use. Are they using the identity of the person or the process that started it versus they're using their own identity? I think there are lots of debates and um, ideas floating around that topic too. I think there are lots of parallels from metaverse to AI agents. But the context is like, at that time it was a hot topic and we wanted to look into the security aspects of it. From a blogging perspective, I can't say that I'm a avid blogger, to be honest. But I do benefit from a lot of Substacks and what people generate. I started to look a little bit like more suspicious to the blogs, given that now AI is very capable of writing very good text. So I think it diminished the value of blogs a little bit. But there are people that I trust. There are like blogs that I follow, which I do get benefit. On the other side of the story is that with AI, it's more polished. We see more the story of the blog is basically more coherent and all. So I think there are also positive aspects as well. But yeah, I mean, I think it's blogging is for me, it's more of like a learning. So that's why when I write something, it's sort of for me to learn and also share what I learn. but yeah, I think everyone may have different sort of like objectives on that.
Maybe we can filter out human generated blogs just using M dash as a filter.
Yeah, yeah, that's a good idea. I mean, some of these posts, like, they it's you can easily tell that. And I also know people who use M dash too, and they're really pissed off because like, they say that I use this in my, like, regular writing, so don't blame me that this is, LLM generated text. So there is that aspect.
Yeah, I know some people will intentionally now add mistakes or typos in their writing just to prove that, hey, I'm a human writing this. So it's a very, very strange times. Now, talking about strange times, everyone seems to have AI in their LinkedIn title. Like you're an actual like AI ML architect. Your work has been in the AI way before it was cool. So how do you see the hype versus reality? What's one thing that makes you shake your head when you see the hype?
I mean, there's definitely a certain level of hype in AI for sure, but it's fueled by the reality. Let me put it that way. And the reason is that, I think AI is now at a place where we can take advantage of it and deliver features and products that would transform the businesses. Um, and we see the example of this, in multiple places. So it already happens. So it's a reality, in my opinion. But in the meantime, I don't yet see that AI is at a place where we can confidently rely on it for all of our problems. And those are the areas, like, I shake my hands, maybe we should slow down a little bit. Obviously, you know, all of us, like, working in this field, targeting autonomous systems, making more things like autonomous and automated. Um, but there are use cases where you can do this today, but then there are use cases you can't because of the reliability requirements, and maybe healthcare and security, may fall into some of these areas. So you have to make sure that the quality is there, because human lives, at the risk here. Another aspect that I can see is a little bit problematic is, um, I think we are a little bit unfair to AI in comparison to human. When we look at some of the use cases in let's say security, I see humans also makes a lot of mistakes, in terms of the extraction of information, or in terms of um, writing, a software code and all. But we are more, you know, careful to, or we are more okay that human make mistakes, versus if AI makes mistake, we are, like, it's on the news. So those sort of problems. So I think we're a little bit unfair to the AI in that sense, but I think that's also normal, because we wanted to make sure that AI actually, not just like get to the human level in certain tests, it actually supersede those. So I think it's also a perception problem too. Um, but yeah, I mean, I think one thing that we need to be careful is, when people say we can automate everything. I think that's where I shake my hands. Like, I can't do that with that indeterminism, with uncertainty in outputs, and with all the cost as well. I don't think we are there yet, but there are use cases where maybe this is possible.
And conversely, what's one thing that you're really hopeful with AI? So let's say in the next 5 years, what's one area that you see massively impacted with AI, and that's something like you're certain will happen?
I think the places where, and this may get a little bit technical, but um, the places that we have verifiable outputs, for example, I can write a code and I can test it, whether it runs or not, or whether what the output is or not. So those are the areas where I think we are going to see a lot of improvements. And this applies to math as well, because you can verify the math solution. You can look at the output and then see if it's correct or not. So the places where you have such verifiable solutions, where these reasoning models started to excel, I think those are the areas where I can see that we will see some more improvements, with more time to compute and all. Um, and So those are the areas. One thing that I am really hoping where AI gets better is the context window and effective use of it. As I mentioned, we discuss about like 2 million tokens, but today I don't think AI is there where this is utilized effectively. So I am hoping that we get to the point where we can rely AI when we put information, it will take this into the account for sure. I think that will opportunities as well, especially in the areas where the volume is huge, like in security or ops on those use cases.
This was the conversation with Fatih Bulut, AI architect at Microsoft, master inventor at his previous place, IBM Research. Fatih, it was fantastic to have this discussion with you. If our viewers and listeners would love to learn more about AI, cloud, and security, what can they do? Where they can find you?
The best place to reach out to me, I think, is my LinkedIn account. I have a website and a blog as well, but the one that's most up to date is my LinkedIn account.
We'll be sure to link your LinkedIn account in the podcast description and the YouTube video description. If you haven't subscribed yet, please subscribe to our YouTube channel. This is ShipTalk Podcast. I'm your host, Dewan Ahmed. We talk about the ins and outs, ups and downs of software delivery. And this season, season 4, we're talking about how AI meets software delivery. Thank you, Fatih.
Thank you, Dewan.